All right, so let's take a look at calculations. I don't think we're actually going to do within subject calculations on homework assignments, but again, I like for folks to have some understanding of where the different values come from. All right, so here is a small data set. We have scores for 4 people. They're all measured 3 times. And notice here, one new thing that I have is what I call the block mean. That's going to be each subject's mean score. And one thing you can see about that is that tells us, when this person's above their average, when they're below their average. Again, that becomes another source of variability that we can explain. How much they vary around that is going to be what ends up going into that sums of square subjects. And we saw the sums of square subjects look so just like the sums of square, the other sums of squares we did. Sums of square total, really no difference here. Again, just all of the individual scores minus the grand mean squared and then added up. Sums of square between, again, as before, number of people in each group, they're all going to be equal here. The mean of the group minus the grand mean. One thing to notice here is that sums of square between is really super small relative to the sums of square total. So you might think, oh, no way I'm going to be able to reject my null hypothesis. But stay tuned. All right, sums of square within. Sums of square within, as before, individual scores minus the mean of the group. And you can see what those values are. I think I may have a couple ones off here, if you'll bear with me for a second. 16, 19, and 20. Oh, no, I do not. My bad, I was reading that incorrectly. Sums of square subject. Sums of square subject is equal to t, which is the block mean, minus the grand mean multiplied by the number of times the person was measured. And then we sum them and we square it. And we can see that that's a really big number. And when we go down to get sums of square error, which just involves a little subtraction, it comes out to only about 9. So what this is telling us is that where somebody scores, a large proportion of that can be explained by the individual subject. All the rest of the statistics you can see here, the F value comes out to actually about 19. That's a very 14.9, I should say. Very low probability, so we reject the null hypothesis here. Again, calculations are pretty much the same. We just have one new component. If you're cool with the calculations for the one factor, this is just adding one additional thing to it.